Many times in research and in our problems in everyday life, we are given a number or we have a sample for which we calculate a number that we're trying to estimate a number for. Those numbers are called point estimates. When we have a point estimate, sometimes we have a certain amount of clarity about where that number came from, or we want to build a confidence interval around that number so we have some bounds as to where we think that number might find of the real number might be within that estimate. So that brings us to confidence intervals. Confidence intervals are really simple. Point estimate plus or minus the critical value from the table divided or times the standard error. Now I'm going to use the examples that I've shown you, examples 2, 3, and 4, to make this make sense for you. So we can do confidence intervals for the mean or the proportion. For example number 2, we have the mu plus or minus the z critical value times the standard error. Now what is the standard error? For our problem, if you remember correctly, we had 82 for the mean, plus or minus at a level of significance of 0.01. We had a critical value for z of 2.58. And our standard error is sigma, which was 10 over the square root of 100. Oh, sorry. Square root value got away from me. So that gives us our confidence interval. And I'll let you do the math for that one. For example 3, we had x bar that we calculated, our average, which was 80. So that's plus or minus. Then we had a t value of t with 99 degrees of freedom, which you were looking up. And our standard error, which was very similar to this one, which was our s over n of 100 square rooted. So this is our confidence interval there. Oh, I missed the 2 here. We have 80 plus or minus. And again, I'll let you do the math. Now we have a little bit different situation for the proportion. In example 4, we had our pi plus or minus, very similar to our example 2, the critical value. And our standard error we mentioned is pi times 1 minus pi divided by n, and take the square root of that whole thing. Now we run into an issue because we don't actually know pi, so we don't want to build a confidence interval around an unknown theoretical pi, but we do have our proportion here that we got from our sample. So simple calculation here is just switch over the pi to p. So we have p, which I believe was 0.80, plus or minus the z critical score. If we're at a level of significance of 0.01 again, we'll say that it's from the chart 2.58. Now we multiply that times our standard error, which our p was 80, which means 1 minus p is 1 minus 0.80, and n was 100. So again, I'll let you do that calculation, and this is how we're calculating our confidence intervals to this point.